What's the integral of secant x? Well, first off, what is secant x? Well, secant x is nothing more than just 1 over cosine x. And let's multiply this by 1. Cosine x over cosine x. So this is nothing more than just cosine x over cosine squared x. And what is cosine squared x? Well, we know from the fundamental theorem of trigonometry that sine squared x plus cosine squared x equals 1. So then cosine squared x is nothing more than just 1 over sine squared x. 1 minus sine squared x, sorry. And then let's just factor this 1 minus sine squared x. And I'm going to distribute the cosine x first. Cosine x times 1 divided by, well, a squared minus b squared. Here we have a squared minus b squared. This is the same thing as a plus b times a minus b. So here a squared is just 1, b squared is just sine of x. So we have 1 minus sine squared x is the same as 1 plus sine of x times 1 minus sine of x. Now let's try to do partial fractions on this little guy right here. So here I've set up the partial fractions, and now let's continue by multiplying both sides by this denominator right here. So that tells us that 1 is nothing more than just a over 1 plus sine x times 1 plus sine x, 1 minus sine x, plus b over 1 minus sine x times 1 plus sine x, 1 minus sine x. Here we can cancel this, cancel. Okay, and now let's distribute this a and distribute this b. So I'm going to rewrite this, and you'll see why in a minute. But I'm going to write it as 1 plus 0 sine x. So here I just added a 0. That's perfectly legitimate. I'll distribute this now. We'll get an a and a b. B times 1 is just b. So a plus b. And here we're going to get a times minus sine x plus b times sine x. So if we factor that out, we're going to get, there's a sine x in both of them, and we're going to get b minus a. So b minus a sine x. And now we can compare these two. Since these are equals, the coefficients in front of the sine x's must equal, and the coefficients in front of the constants must equal. So from this, we'll get one is equal to a plus b, and 0 is equal to b minus a. So I'm going to do this on the side right here really quick. B minus a equals 0, and a plus b equals 1. This first equation tells us that a is equal to b, And then plugging that into the second equation, we'll get a plus a equals 1. So 2a equals 1. And that will give us a equals b equals 1/2. And now we can substitute both of these into these fractions right here. So I'm going to do this all in one step and rewrite the integral. So we have integral of secant x dx is equal to the integral of cosine x times 1/2 1 plus sine x plus 1/2 1 minus sine x, and of course dx. And since the integral operation is a linear operation, we can split this up into two integrals, and I'm going to pull out the 1/2. So that is going to give us 1/2 integral of cosine x over 1 plus sine x dx plus 1/2 integral of cosine x 1 minus sine x dx. Okay, and now we can do a u substitution for both of these. So here I'm going to set this equal to u, and here I'm going to set this equal to u. So we'll get u is equal to 1 plus sine x, and from that du is equal to cosine x dx. And we find that right here. Here we'll have u equals 1 minus sine x, and then du is equal to minus cosine x dx. And that's going to be right here if we add a minus sign. So now if we rewrite this integral, we'll get 1/2 integral of cosine x dx is just du divided by u, and then minus 1/2 integral minus cosine x dx is going to be du over u. And we can't just combine these because these are different u's. If you want, I can put u1 here and u2 here. So we can't just combine these. So this is not just equal to 0. This is actually a different integral. So we'll do each of these separately. We'll get 1/2 ln u1 minus 1/2 ln u2. Now, if we remember our natural log identities, we see that subtracting two natural logs just means they get divided inside 1. So we can actually rewrite this as 1/2 ln u1 over u2. And now, what is u1 and u2? Well, u1 and u2 is simply just 1 plus sine x and 1 minus sine x. So that's simply the integral. But of course, we can simplify this a little more by rewriting it like this. So we'll have 1/2 ln 1 plus sine x 1 minus sine x And we'll once again multiply it by 1. This time just the conjugate of the bottom, which is going to be 1 plus sine x. Don't forget the plus c. And here we'll get 1 minus sine squared x. Here we'll get 1 plus sine squared. Here we'll get 1 plus sine x squared. And here we'll get 1 minus sine squared x. But remember, that's just cosine squared x. So we actually have cosine squared x plus c. And since both of these are squared, we can just take this square out and move it to the entire absolute value. And if we remember natural log rules, if the inside of a logarithm is exponentiated, we can move that exponent to the front. So what we're actually going to get for our rewritten answer is the secant of x dx is equal to 1/2 ln 1 plus sine x over cosine x plus c. And, oh wait, no 1/2. The ln of 1 plus sine x over cosine x plus c. And what is this? Well, here we'll have 1 over cosine x, that's just secant x, plus sine x over cosine x, and that's just tangent x.